Welcome to EDU World Space.
This question asks us to evaluate each of these expressions in part A. So let's do that first. 2 times 1 is 2. 1 plus 3 is 4. Times 2 is 8. 1 plus 3 is 4. 4 plus 5 is 9. Times 2 is 18. And 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 6 is 9 plus 7 is 16. 16 times 2 is 32. This is for part A. And we'll see what this means in just a moment. Then in part B, it asks us how the atomic numbers of the noble gases relate to the numbers in part A. So just moving top to bottom down the periodic table, the atomic numbers of the noble gases are 2, 10, 18, 36, 54, and 86. And how these numbers relate is if you look at the differences between each atomic gas, you'll see that they only jump by these values. The difference between 2 and 10 is 8, which we see here. 10 and 18 is also 8. 18 and 36 is 18. 36 and 54 is also 18. And then 54 and 86 is 32. And so that's how they relate, but it's also that these jumps represent filling a new subshell. When you move from helium to neon, you're adding electrons to the s and the p orbitals, or 8 electrons. When you jump from neon to argon, again, you fill an s and a p orbital, so 8 electrons. But when you move from argon to krypton, you're not only filling the s and the p, you're also filling the d orbitals. That's why you jump to 18. Same thing here, you're just adding s, p, and d, but when you jump from xenon to radon, you're also filling the f orbitals, and so that's how you get this jump of 32. So each of these corresponds to how big the subshell is that you're filling when you jump down the periodic table. And then in C, it says, based on what we discussed in chapter 6, what does this 2 represent? And the 2 comes from the fact that each orbital can contain 2 electrons. This is because of the Pauli exclusion principle. I'm going to abbreviate this, which says that any orbital can only contain 2 electrons with opposite paired spins. So the s orbital contains 2 electrons. The p orbital, of which there are 3, can also contain 2 electrons. There are 5 d orbitals, 2 electrons. 7 f orbitals, 2 electrons. So the Pauli exclusion principle dictates what this 2 means.